All right, everybody. Welcome to the video here for lesson number 7 on polynomial identities. So the first thing we have to be able to do here is understand what is an identity. An identity is us trying to show that both sides of the equation are the exact same. So if we were to look at this first example, there's really nothing I can do on the right-hand side, so I'm going to really have to do my algebra on the left. So if I do some multiplication here of x, y, we're going to get x squared, xy, xy, and y squared. So it's going to give me x squared plus 2xy's plus y squared minus. Now this is the exact same thing just with a minus here, which is going to give you a minus here and a minus here. So we're going to get x squared minus 2xy plus y squared all equals 4xy. Everything here, when you distribute this, is going to cancel except for this term. It's going to become positive, so that tells us 4xy is equal to 4xy. It's an identity. This also, by the way, would generate another set of Pythagorean triples. So moving on to number 2. This is us proving the factoring method that we learned in lesson 6, right? The sum of two cubes. So all we have to do is on the right-hand side do some multiplying. X and A. I made it too low here, so I'll just put this on the bottom. So we have x cubed. We have ax squared, negative ax squared. So those cancel. We have negative a squared x, positive a squared x. So those cancel, and a cubed. So that's enough work to show us that this is true. Number 3 gives us this problem talking about integers. So it says, Mr. Hines was exploring the following statement. The sum of the product of 3 consecutive integers and the middle integer is the cube of the middle integer. So what that's telling me to do is to add the 3 terms together and then add that to the second term, and you wind up getting the cube of the middle term. All right, doesn't always work. All right, so if we add and multiply and do what it asks us to do here, so we have 12, 24 here, right? Sum of the product and the middle term. So if I do 24 plus 30, well, that's 27. And that's the same thing as 3 cubed. So it works. The same thing for the next one. So we have 30, so 120. 120 plus 5 is 125, which is 5 cubed. So yes, that works. Then it wants us to prove the identity. Let x be the middle number. So if x is the middle number, I'm going to take x minus 1 times x plus 1, add x, and that's going to be the same thing as x cubed. If I could show that, then I prove my identity. So if we do that, we have x times x squared minus 1. I'm getting that because we know how to factor, right? Plus x equals x cubed. Distribute x cubed minus x plus x equals x cubed. X's cancel. Identity proven. Next one asks, is this an identity? To prove that this is an identity or not, all we have to do is multiply out x plus 4 squared. Now, if you're a box person, do your boxes. Or, if you remember the rule from last year, you know that these two things are not equal to each other. Number 6. Number 6 asks us to prove the side lengths are going to make a right triangle, similar to one that we did in class. So we're going to have x squared minus y squared plus 2xy squared equals x squared plus y squared squared. So if you make some boxes to do your multiplication, all right? Nice thing here is, again, we see the same thing. Look for that same structure. So I have x to the 4th minus x squared minus x squared y squared, and a y to the 4th. So we are going to have x to the 4th minus 2x squared y squared plus y to the 4th plus 4x squared y squared equals x to the 4th plus 2x squared y squared plus y to the 4th. combine your like terms, and you'll see this checks. At this point, I'm going to stop the video because I'm running out of time. There will be a second video here that'll show you the rest of the homework, so just make sure you watch both. See you soon.